So we have a new chapter which is chemical bonding and structure of molecules. So I'll be giving the introduction of this chapter. So types of chemical bonding. So here we have two types of chemical bondings. First one is interatomic, and second one is intermolecule. So basically in interatomic we'll study about ionic and covalent bond, and we'll further study about coordinate bond and metallic bond and intermolecule, the type in which we'll study about like van der Waals force, and here we have got 5 types of van der Waals force, 5 types, and we'll study about 2 types of hydrogen bond. So here we have the introduction of this new chapter. What we'll be studying in this chapter. So let's get started. So firstly we'll discuss about ionic bond. Today our topic is basically ionic bond. We call it also electrovalent bond. So ionic bond is basically between metal plus non-metal. Ionic bond is between metal plus non-metal. Basically it happens between metal and non-metal, like metal gives complete transformation of electrons, complete transfer of electrons from metal to non-metal. Like let's take an example of it. We'll take off NaCl. So Na. So basically Na, which is like NaCl. So Na has what we call it. Na has 2. I'm writing the what we say electrons. Like Na has 1 electron in the valence shell. So it will transfer. Na is basically metal, so it will transfer 1 electron. It will transfer 1 electron positive plus electron. Basically it have transferred 1 electron of valence shell. Basically metals will transfer the electrons of their valence shells. Now we'll talk about Cl. Cl has took electron from Na, so Cl plus Na is equals to Cl negative. So basically here we had here we had 281. One was in valence shell. Now we'll have 2 and 8. So here we had 2, 8 and 7. So now here we'll have like 2, 8, 8. Octet has completed. Like this ionic bond is happened between metal plus non-metal. So like let's study about Lewis dot what we say structure Lewis dot structure law. In this law we'll have to only structure about what we call it, we'll have only make a structure of metal plus non-metal. Like let's take an example of Mg. So Mg 2, 8 and 2 in the valence shell, so it will transfer Mg plus 2 electrons. Mg Cl. So we'll take 2Cl. Like Mg has transferred 2 electrons, so we'll take 2Cl and 2Cl plus 2 electrons. Now it is 2Cl negative. Like previously it had 2, 8 and 7. Now it is 2, 8 and 8. Octet is completed. Octet is completed with 2, 8 and 8 in the valence shell. So like now we'll have to give a structure. This is also a structure, but we'll give another structure which is like we can structure like this Mg, like 2 electrons in valence shell, and it's unstable, so he'll transfer electrons. Now we'll have 2 Cl. We had 2 Cl and Cl, 2 Cls, like 1, 2, 3, 4, 1 and 2, 3. So Mg will transfer 1 electron, which will be octet complete. Like here it will be also same 1, 2, 3 and 4, 5, 6, 7. So it will give 1 electron to it. So octet completed. Like this V shape we give structure to the ionic, what we call it, ionic bond. Now we have another topic which is electrovalency. So in electrovalency we get the number of electrons lost or gained. We get to know the number of electrons lost or gained. Like firstly we'll look into first group. So in first group we have like Na, we have Na potassium. So in their valence shell their electrovalency will be 1, because in their valence shell there is 1 electron. So the first group elements have ability of 1 electrovalency. Like that second group In second group we have helium and many other. So in second group the valency of them will be 2 electrovalency basically. So like that we'll look of like group 13 group. So in 13 group we'll have yes L and many others. So they'll have the valency like 13, it is 13 2 8 and 3. So they'll have the electrovalency of 13, oh sorry 3. They in 13 group elements they have the electrovalency which is 3 in their valence shell. In their valence shell there are 3 electrons. So after that we have properties. We'll look into the properties of ionic compound. Properties of ionic compound. So first one is basic properties: metal plus non-metal, and metal plus non-metal, and we can write found in ionic bond always found in solid state like NaCl we found in solid state. So these are in solid state, that's why their melting and boiling point will be higher because these are in solid form. And if ionic bond like metal plus non-metal are in aqueous or molten state, so ionic compound are like what we call it. If the fourth property we have is if ionic compound is in aqueous or molten state, so it is good conductor. It is good conductor if it is in what we call it solid state. If solid state, it is bad conductor. Why in solid state it is bad conductor? So basically the force of attraction between ions like between NaCl positive negative, so the force of attraction between them will be higher, which is called strong force, which is electrostatic force. The force will be electrostatic force, which is strong force. So these ions are packed so that they cannot conduct. What we say, they can conduct but they are bad conductor when they are in solid states, and if they are in aqueous states, so their ions are completely free. So that's why in aqueous state they are good conductors of electricity.